Welcome to Introduction to Generative AI event. In this session, I'm going to explain very basics of the hardware of the generative AI and the very fundamentals of artificial intelligence, machine learning, deep learning, and also prompt designing. If time permits, I'll show you a project that all of you can do with generative AI. And And the term generative AI has two separate words, that is generative and AI, which refers to artificial intelligence. And the meaning of generative AI is generating new content from the pre-trained data, that we can generate almost anything like code, images, text, or either audio or video. And the large language models that can generate different types of content are known as large multimodal LLMs. And artificial intelligence is a branch of computer science that deals with making computers and machines smart enough so that they can behave like humans. For example, they can learn or understand language and recognize objects and patterns. For example, we are using Instagram and other social media platforms. And those algorithms or artificial intelligence models are trained on the data that we are looking at, the feed or the reels. They'll train the model according to your personalization and the feed you are looking at and liking those feed. So it will understand the patterns and the feed that we are looking at so that it will recommend more likely feed to us. And at first we are controlling those algorithms, and now the situation is like the algorithms are controlling our emotions. And then generative AI is now a boom, and why is everyone talking about it now? And making generative AI requires software, hardware, and data. Due to rapid increase in the hardware, like GPUs and CPUs got more powerful, so that they can emulate these large language models. And the software, has been a lot of research in software, like transformers and BERT models, to make these large language models. And everyone is using the internet now, and there is a huge amount of data to train that large language models. So generative AI became most popular in these recent years. So due to the rise in chat GPT, there is a tech revolution on artificial intelligence, and every company is going with the race of artificial intelligence to take over each other. And the mainly to emulate these large language models, we need CPUs and GPUs. And if you don't know about what is a GPU, basically a GPU is a graphic processing unit, which is used in before large language models. It is used for rendering games and 4K videos. And you can see a GPU will look like this. This is attached to the motherboard of your PC. And we can imagine a GPU like a group of factory workers, and the CPU is like a CEO of the company. And basically the CPU is like more like a journalist. It is good at performing complex tasks and decision makings, and it works on a single job at a time, like a CEO. It will works on a single task which will perform calculations in a single at a time only. And we have more due to the increase in CPU also, we have more cores and threads in CPUs. But emulating these large language models requires a lot of complex calculations that need to done at a time. So CPUs are not good at running these large language models. And as GPUs are like factory workers, they can do great. They are great at simpler repetitive tasks. They can work on many tasks at the same time, which is best use for these large language models. If you give any prompt, there is a lot of mathematical calculations and probability that is going in the background. So it will it will calculate all the probability at a time. So GPUs are very good at doing all of these tasks. And in the recent trend, due to the increase in large language models, there is another chipset also that became a trend, is a language LPU, which is a language processing unit, which are a chipset specifically designed for running these large language models. Mm, the ChatGPT and Gemini and all other large language model providers are using these GPUs in their servers, but there is a one company called Grok which uses LPUs, which is language processing units. I will show you the difference between the CPUs and the GPUs and LPU. Let me share my screen. If you see, if I ask this ChatGPT to write a leave letter, you can see that it's generating like 20 or 30 or up to 50 tokens per second, which are in large language models we call these words as tokens. So this ChatGPT or Gemini or any other large language model uses these NVIDIA graphic processing units to run these large language models. But there is this company called Grok which uses open source models on these LPUs. If I ask, so you can see that it generated within a second. So you can see that it is generating up to 800, it will generate up to 1000 tokens per second, which is pretty fast. These chipsets are specifically designed for emulating these large language models. So you can't use these LPUs for other purposes. And then how machine learning and AI are related. And machine learning is a subset of or a type of AI that focuses on building systems that learn from data and behave like humans. It is a program or system that trains a model from input data. The trained model can make useful predictions from new or never seen before data drawn from the same or used to train the model. Suppose if we consider a machine learning model, which is a classification machine learning model, like we'll train the data with the cat images and dog images, we'll train that model, and then if you upload an image, it will try to predict whether it's a cat or a dog. This is the type of artificial intelligence which focuses mainly on building these models. So it gives computer the ability to learn without explicit programming. We need not to upload every image and they train the model. So we can directly train the model with a huge amount of data so that it will learn and predict with unseen data. So there are two types of mainly there are two types of machine learning models. There are different types of machine learning models also, like reinforcement learning, but they are mainly classified into supervised learning and unsupervised learning. And in supervised learning, we have labeled data, which means if we have a data, like I said, our data will have these tags. Like I'm training this machine learning models with the dog and cat images. I'll insist the machine learning model that it is cat, it is dog. We'll give a tag or name like structure to this labeled data. But in supervised learning, we'll use unlabeled data, which is text files and these videos and photos and all other stuff. So like if you consider text files, they are not structured data and they will not have any labels. So these are the main two types of machine learning models that we are using. And what is deep learning? And deep learning is a subset of machine learning models which uses artificial neural networks to train these machine learning models. So this is the Venn diagram of artificial intelligence. You can see that the machine learning model is a subset of artificial intelligence and deep learning is a subset of machine learning models. If we train these machine learning models on artificial neural networks, we call it as a deep learning. So these neural networks are inspired from our brain structure. As we have neurons and neural networks in our brain, the same things applied for these neural network models. So we have these input layers and output layers, and we have different hidden layers in between these layers. So it will understand the patterns and the trends that are in the data more efficiently and accurately than those models. So we use deep learning models to train for more accuracy and to train on more data. So for example, if we are considering climate data, we have a lot, if we have a huge number of data and there are different kinds of patterns that occurs in climate data. So we use this, there are different types of neural network models like convolution neural networks or artificial neural networks. So we use these different types of neural network for different cases. So these deep learning or neural networks will learn on neural networks. So it will have a huge accuracy. Like our algorithms, like I said, the Instagram uses these deep learning algorithms to predict our patterns or the feed that we are going to look at. So before diving into large language models, most of you have done these labs. So you heard this term API or you have seen this before API, which stands for Application Programming Interface. And if you don't know about application programming interfaces, so it is it connects between the end user and the server at the back end. So for example, let us consider API like a waiter in the restaurant. It will connect the customer to the chef. Like it will, the waiter takes the order and gives the order to the chef, and then the chef cooks the food, and it will return, and they'll return the food from the kitchen and deliver that order to the customer. And API is more like a connecting different kinds of apps. For example, every application that we use uses different types of APIs from different systems. Like if you take an example of Uber, in Uber is not a standalone application. It will uses different types of APIs. Like for example, we see that Uber will have maps, and the map they use is Google Maps. They'll take the API from the Google Maps and they'll integrate that Google Maps into the Uber platform based on their use cases. And we'll have different types of APIs that Uber uses. Like for feedback, they'll use a different platform. They'll take that API from that platform. And for payment purposes, they'll use different platforms like Razzo Pay, etc. And every application that we use uses different types of APIs for different purposes. So, and is deep learning similar to generative AI? Yes. And generative AI is a subset of deep learning that generates contents from the patterns and the data that it has been trained on. Like for example, you can see this Venn diagram, like artificial intelligence is a subset of machine learning and it is a subset of deep learning, and generative AI is a subset of deep learning. And large language models will also come under this deep learning subset. So these are the basics of large language models. In Gen AI, um, I hope you got an idea about these basic idea about this. What is machine learning, artificial intelligence, and generative AI? Am I going very fast, and or is it okay? So, so reply anything in the chat. I know we are MBU students will does not reply to any replies, even it's online sessions or offline sessions. Guys are very tough to convince. Thank you, Sanjana, for responding. Like, okay, and let's dive into the presentation that Google has sent us. Choose representative, and there is an evolution for every century. Like we have steam power revolution in 18th century and electricity in 19th century, and we have information technology revolution in the 20th century, and today, that is the 21st century, we have artificial intelligence. So before diving into artificial intelligence, most of us have a fear that artificial intelligence will replace us, but it's not going to the case. Yes, artificial intelligence will replace the repetitive task or boring task that human will do, like a low skilled jobs, but they are not going to replace the every skill or every industry that human will work. Like who will replace these humans are like humans will replace humans, like the humans who know how to work with this artificial intelligence will replace the humans who don't know all of this stuff. So we need to be updated about these artificial intelligence and working on these different types of artificial intelligence too, to stay updated and to not to be replaced by any of these artificial intelligence. We need to stay ahead of these artificial intelligence in order to not to be replaced. So this revolution started at Google and we continue to innovate. For example, in 2017, Google introduced transformed architecture, which is the architecture that LLM works, which they researched about this transformers architecture, and this is the fundamental of the large language models. And in 2018, they launched these BERT large language models, and in 2018, they launched AlphaFold, which predicts the structures of known proteins. And in 2019, they released this open source large language model named T5, which is the text to text large language models. And then from 2021 onwards, after the launch of the ChatGPT, there has been a revolution in the AI industry, and every company is competing with each other. And in 2022, Google launched this PaLM, which is a large language model, which is a single model to generalize across the domains. Like it is more like a multimodal LLM. And in 2023, they launched this BART, which is a conversational AI service powered by Lambda. And now it's called Gemini in 2024. And we have different types of models like Gemini 1.5 and Gemini Pro models and Gemini Pro Vision models for different use cases. Mm, and basically, I'm saying from the starting of this presentation, like large language models, and you are confused about what is a large language model. And suppose consider this whole scenario as a black box, like a computer as a black box. In traditional programming, if we specify this as we should tell that it's a type animal, it has four legs, it has 2 ears, and it has fur. Like we'll in machine learning models, we'll train this with the dictionary format. And if you worked on these machine learning models, we'll come to know about this traditional programming. And with the wave of neural networks, we can train this black box as we can show these images like this is cat, this is dog. And if you ask after the training of the black box, if you ask if you show this image of cat, and if you ask is this is a cat, and it will respond as yes. And this is the wave of neural networks. But when it comes to generative or large language models, we'll train this black box with a huge number of books. So it will learn on this millions of data about cats and other stuff. And if we ask what is a cat, it will learn from the data, and it will generate a new content from this pre-trained data. Like a cat is an animal, like other stuff, it will generate these large language models. So first, some vocabulary about these large language models. A generative model is a machine learning model that produces content including language, code, imaginary, music, and video. Like we have Sora for video to video, and we have DeepGram for generating this music, and we have imaginary like DAL-E or Gemini Vision models for generating these images. And we have different types of code editors like GitHub Copilot and Llama code, which is fine-tuned model of the Llama. And a large language is a machine learning model that are really good understanding and generating human language. Large refers to both size and complexity of the neural network itself, as well as the size of the dataset it was trained on. Can also be used for non-generative language tasks like classification. Suppose if we take an example of the free version of ChatGPT, that is GPT 3.5, it is a 175 billion parameter model. 175 billion. So that much billion neural network, and that is the data that is trained on. So it is a huge a large language model. So it requires a lot of GPUs and computational power to process these large language models. Our laptops, suppose if we have I have a Ryzen 7 laptop, it will emulate up to 7 billion parameter. If I use 7 billion parameter large language models to run locally, and it's stacking a lot, and I have another with GPU, so it can go up to 13 billion parameter. So if we take the example of GPT-4, it is 315 billion parameter large language models. But the more the complexity and the parameters of this large language model, the more it is you, the more it will understand and generate like human language. And the transform is the neural network architecture underlying most of the today's generative AI platforms, which is published by Google in 2017, which is the foundation of these entire large language models. And if we consider these large language models, it is mostly like the keyboard that we are using. If I type honesty is the best in my keyboard, and it will predict the next word that I am going to type, like policy, way, approach. And the most likely word that we are going to use like a policy, and the next like it will computate all of these upcoming words based on the probability of the word. I'll explain more in detail in the later of this presentation. And for example, if I give this prompt like to be or not to, then it will try to predict the next word like be. Like Mumbai is in India, what London is to? It's England. And masala dosa is a popular South Indian dish. So it will try to predict these bold letters. And the prompt is the text that we feed to our model. Like I used write a letter, a leave letter, like that is a prompt. But there is another section like prompt design. It is an art and science of figuring out what text to feed your language model to get it to take on the behavior you want. Like I'll explain this about the prompt design. And the way we want to get the output from the large language models is prompt engineering. We have an entire now, due to the increase in these large language models, there is a trend like prompt engineering, which is used to get the required output from the large language model. So this is the zero shot the prompt that we like. I can ask write a poem about cricket. It will generate a poem on the cricket. This is a zero shot prompt that we are going to feed to our large language model. But there are different types of prompt design. Like this is a few shot method. Like for example, I'll give this prompt like convert from English to French. Then I'll give this examples of the some of the words, so that if we give this like onion, so it will generate the structure, it will generate the response of from the large language models with this structure only. So this is an example for few short. Like for example, if I use this convert the Python to JavaScript, if I give example for Python like print hello world, and in Java console.log hello world, and for Python for x in range 0 to 100, and we are invoking the large language models to write for the JavaScript. Like this is the instruction that we are giving, and this is the example, and this is the input that we are feeding these large language models. And we are nudging the LLM to output JavaScript. So this is the example of few shot. And like prompt design is very tricky. We need a lot of examples to learn about this prompt designing. And it is the art and science of figuring out what text to feed your language model to get it to take on the behavior we want. And the future is going to be uh, the hottest program new programming language is English. If we know how to get the required output response from these large language models, we can do everything we want. Suppose if I want to generate an application using Python, if I know how to use these prompts to get the required output, the entire large language model can generate the entire code for this, for the application that I want. And then there are some observations or limitations for these large language models. These large language models are designed to predict the next word in a sequence. They are not required to be truthful when doing so. So these large language models can generate possibly looking statements that are irrelevant or incorrect. That like we should fine tune these large language models according to our data. And and I'll explain you about the temperatures and other things. And these large language models will undergo hallucinations, which is they'll generate these false statements, or they'll understand our context in a different manner, and they'll generate the different type of content. So this is the way that LLM works. If it generates the honesty is the best, then it will calculate the probability of the next word. Like if I give input like the sky is full of, then it will have different types of tokens like stars, clouds, birds, and dash. This is the probability of that word that will occur after this prompt. Like it will calculate the probability which word to return after that the sky was full of. And there are two different types of decoding strategies, which is greedy decoding, which will which will generate the word which has the highest probability. For example, if I use greedy decoding, if I give input like the sky was full of, then it will generate stars. The sky is full of stars. But we have another type of decoding techniques, which is random sampling, which will generate the random sample over the distribution, and it will give the random sample of that word, which is not required if we want more accuracy. But if you want to our large language model to be very creative, we can use this random sampling. And the temperature for a large language model is a number used to tune the degree of the randomness. Like the more the temperature, the more the large language models will predict the random words. Like the lower the temperature, it will generate the less randomness words, which is the more accuracy the generated text is going to be. If the temperature is 0, like generally better if you are using these lower temper for better task like Q&A and summarization where we expect more correct answer, then we'll tune the large language model to lower temperature. And if you want to create a if you want to generate a creative response, we can increase this temperature, like it will generate more randomness in the words. For example, if you want to work on this, like I'll show the, and this is the AI studio of Gemini model, so that we can fine tune our the temperature of the, like for example, you can see that it's generating text. The more the temperature is, the more it is going to creative. The less the temperature is, the less it is going to be more creative. Like if I want to work on these models up to May 4th, these working on this Google AI Studio is free, but now from the May 4th they are restricted these API keys and working on these Gemini models for paid users only. And to show you, I'll use this Grok only. And Grok has this Grok playground. Like I am using this, you can use different types of models like Mistral AI, which is an open source, and these are the different types of models like Llama 2, Llama 3, 8 billion. This is Llama 3 8 billion model, and this is Llama 3 70 billion large language model, which are open source models developed by Meta. These language models belongs to Facebook. So I'll use for now I'll use Llama 3 8 billion parameter model. So you can see that the temperature is set to 1. If I ask it to generate the leave letter, you can see that it generated pretty well, and it's in a structure format. And if I increase the temperature of the LLM up to 2, you can see that it will generate random outputs. I increase temperature, and you can see that the text is not structured format. Like there is a more randomness in the text that is generating by the large language models. So these temperatures are by default, these temperatures are set to the fine-tuned parameter of these large language models to get a balanced output that is not more creative, and that is not more balanced. So we use temperature 1, which is the probability of the predicting the next word. So this is about this temperature and fine tuning these large language models. And I hope you are getting what I am saying. So I will continue my presentation. And And after the temperature, we can see that what are large language models? Like I have said, they are algorithms that can recognize, predict, and generate human languages. And they are pre-trained on petabyte scale text-based data sets, resulting in large models with tens and thousands of billions of parameters. And the LLMs are normally pre-trained on large corpus of text followed by fine-tuning on a specific task. If I want a large language model for medical diagnosis, so I'll train more the language model on this medical data so that we can fine-tune this for these medical purposes. And LLMs can also be called large models and generative AI. And there are different types of large language models that serve different purposes. Like we can use different large language models for searching, for conversation, we have this chat GPT and everything for conversations. We have DALI for content generation, for image generations, and Sora for video generation. There are different types of large language models required for specific tasks, and a large language models which can be used to do all of these specific tasks or a general large language model is called a multimodal large language models. And there are a lot of application LLM applications in the industry. Like we have customer support, we can create interactive human like chatbots in customer supports. We can do conversations for agents and sentimental analysis and entity extraction. We can use for domain specific entity extraction in healthcare or case documentation summary. Or we can use to generate in technology. There are a lot of use cases for these LLMs for generating text, and in retail also we can use these large language models to generate product descriptions. So you can see that these large language models replaces the basic and repetitive tasks that humans will do. And in finance, in for example, if we take this retail industry, for example, like Amazon, they need to give a lot of description about their products, and humans should write all of these descriptions about these products, which takes a lot of time. But if we use these large language models, they can write pretty well, and the generation will be very fast. And in media and gaming, we can design game storylines or auto generate blogs, articles, or tweets, or grammar correction and text formatting. We can see that there are different kinds of art, animations or animated videos or films, short films that are coming by these generated by these LLMs. And to learn these LLMs are I will not say very easy, but it is easy when compared to other domains. That and for example, in traditional machine learning, we need to have a lot of training examples. We need to have ML expertise. We need to have this compute time plus hardware. We should think about minimizing the loss of function or increasing the accuracy of these machine learning models. But when it comes to a large language models development, we don't need any training samples, we don't need any expertise. Like if you have worked on this generative AI labs, you never you don't have any training samples or anything. And Google have this infrastructure, these large language models and everything. We should work on top of it, or we should fine tune this according to our use cases. So we need not to do everything from the scratch. We need not to develop in large language models. We need not to scrape the entire web data to train that machine learning models. We need not to have a high computing power or server in our room to build these large language models. We can use these large language models which are existing, so that an LLM engineer should know about this how these large language models works and this prompt engineering. But an LLM engineer or a generative AI engineer works more on working on this flow of LLMs, For example, if I want to create a interactive customer chatbot or a voice assistant, like I have worked on a voice assistant before. I use these deepgram, which is a these large language models which will convert the speech to text, and then the text is given to the grok, like I have said, the grok lpu using the api. Then the grok will generate the response from the prompt that I have given. Then this deepgram will convert the text to speech. So as grok is very fast, and it has low latency, and the deepgram has very good text to speech and speech to text models. So it is very easy to create these customer service chatbots. So we have this grok lpus and large language models, and we have these deepgram text to speech or speech to text models. We should work on these flows to connect these different types of LLMs to create the specific use case we want or the specific product we want. So this is all about the generative AI and working on these large language models. So I hope you got an idea about the working on this generative AI. And I want to keep this session to be very basic. I can go up to fine tuning and all of the stuff, but it will you will get confused by all of this stuff in a single session. So the session completed in 50 minutes, but I'll show some of the projects that we can do with these large language models. Like you can work on this large language. There are different types of beginner projects that you can work with these large language models, like RAG applications, which is retrieval augmented generation applications. And if you are fine with it, I'll show a simple project of this RAG application. So please respond anything in the chat session. And how is this the presentation? Guys, please respond. Okay, fine. And if you are wondering who am I and what I do, I'm a second year data science student in this Mohan Babu University, and I'm working as a cloud captain at Amazon Web Services. I'm a cloud captain for India region, and recently we established this AWS Cloud Club also at Mohan Babu University, like GDSC, and we have Geeks for Geeks Campus Mantri also. He's Aslam from AML, and we are trying to build a tech community at MBU, so that so you guys will have more industry related experience. Give me a minute. Are you ready to look at the project or something that we are going to do? Like we have a lot of time, so I'll show a real world project that we are going. So let me share. I'll show the demonstration of retrieval augmented generation. I'll first explain about the flow of what it does, and then I'll explain about all of, and I'll show this working demonstration. And also we won IBM technical project presentation with this project only. So this is the basic workflow of the retrieval augmented generation project. You will understand when I demonstrate the project. And it will have a more interactive interface like a chat GPT, but we can upload different types of files or links so that it will generate responses from the PDFs or the documents that we have given. So, for example, if I ask chat GPT about me, uh, no one trained about the data, no one trained about my data to that large language models, so it will respond in a different, it will generate a different response. But if we are using, if I want to develop a chatbot for my company, if I have a company, I'll scrape my entire company data and make it into a PDF. Then I'll use this RAG application to fine tune this large language model, so that if anyone asks about my company, it will generate responses from the data that I have given. So if we give data, it will extract the information and it will convert that data into the text chunks, and then it will embed it, the text chunks, like in embedding. It will in embedding stage, it will embed the text chunks which are interrelated to each other. Suppose if I have a contact information of our company, it will embed the contact information text chunks into embeddings, and they'll store this, and will store these entire embeddings of the text chunks in this databases. In our case, I'm using Postgre database in Docker. For scalability, we have done all of this. So this is the data preparation stage that we are going to do, and this is the retrieval augmented generation stage. Like if we give an query, if or like a prompt, it will convert that prompt into embeddings, and then it will search for the relevant data or embeddings that the user given the prompt in the database that we store all of our data, and it will extract the relevant data from the vector databases, and the context, the prompt, the relevant data will be sent to the large language models. In our case, I am using Grok LPU, which is a llama 8 billion parameter model. It will send the entire data to the large language model in the Grok through the API. That is why I said API plays a major role in these large language model workflows. It will send the entire data to the large language models. It will generate a response, and the response will send to my front end with that API only. So this is the basic workflow of the project. I'll show the demonstration of the project. And I am using nomic embed text for text embeddings, that is by Olama, which is a company which gives us an user interface to learn to run these large language models locally. So I'm pulling this. Next, I'm starting my database. Docker. And we have did all of these. You can directly store these entire text chunks in your computer locally. But due to scalability, and I want to deploy this as a real life application, so I'm using this all of these. Let us check. Yeah, you can see that our database is also running, and I'll activate my virtual environment. Mm, Virtual environment activated. And this is the Grok API key that Grok has given me to different people. And whenever you create an API key, you will have a different this Grok API key address or any API. If you want to generate an API key with any company, they'll give an API key so that they'll know who is accessing this content and what they are accessing. So I'm giving this declaring this Grok API key as environment. Let me run. So this is the front end. It look like more like a chat GPT, but we have this section like we can select the large language model. We can select the embeddings. We can add any URL of any if I want to know about Narendra Modi, or I have my own blog that contains my data. I can give the URL of that blog so that it will extract the text from the data to convert. So I have given this URL or this drag and drop files here, and in future I'm going to add a CSV file. You can directly add CSV file and do entire data analysis here only. Like for example, I'm giving my IBM syllabus unit data warehousing unit 1 PDF. So it will be we can directly import up to a 200 MB file, and you can see that it is splitting the PDF into different pages and different chunks and different chunk sizes. And the data, you can see that the document is loaded. If I ask it what is, you can see that it's predicting the next word that I am going to ask. And if I ask what is data warehouse, you can see that it's generated the data from the PDF that I have given. So if I ask to summarize this PDF, and it will summarize the entire PDF. You can directly import an entire textbook or a semester syllabus of your subject, and it will summarize with if I ask if we have an faculty like some of the faculty will give us, we should write the text only, we should write within the PDF they have given, so it will be very useful. It will not directly generate the as the sentences, it will understand the context and it will search for the relevant data in the databases, and then it generates this text from the PDF. So you can do the same thing with the URL also. And in future, I'm going to add the CSV file so that we can directly import CSV file and we can ask like which is a minimum remove null values, or else you can directly ask it to draw graphs. And we can fine tune this across like we can use these to uh, generate SQL statements, or for example, let me and Grok has this different platforms to play with. Where are this project? So these are the projects that developed by. Hmm, I think the resources section. Let me search in Google. Yeah, in Grok documentation, we have these conversational chatbots or function calling or create a machine learning assistant. Suppose if I want to use this machine learning assistant, you can directly import. If I want to predict the sales prices of the data, like the main project that beginner uh, machine learning learners will do is like they will predict the house prices or this Titanic data set or Iris data set. So we can directly import that PDF file and we can ask give it a prompt like predict the sales price of houses based on features like. So it will generate the entire code of the machine learning models. You can directly paste this and it will generate these graphs and everything. So these are the use cases of these large language models. So I hope you got an idea about how these large language models, we need not to create an entire large language models for our own. We need to fine tune this according to our wish. And I wanted to show you the voice assistant that I have given, but it is in the Linux. Oh, mm. And if you want to pursue career in like generative AI, you need to learn about how this works and how the flow works. You need not to learn everything in detail from the beginning to the end. So you can fine tune these machine learning models if